Hello everyone and welcome to this new tutorial, and in this tutorial we're going to talk about generics. And generics is one of the very basic fundamental aspect that has since dominated the Java programming language, or you could more specifically say that it has dominated application programming or the programmer's preferences due to its type safety mechanism in Java programming language. And the reason why we're going to talk about this is that when I've learned about generics, I didn't actually find a lot many help, you could say, when it comes to from very many YouTubers, but there are awesome or great videos that were made about the entire Java suite. But I felt that there were some things that were lacking. Nonetheless, if you're not quite familiar with the Java programming language, go to the description below and you'll find several links to other YouTubers or other links, useful links and resources where you can learn about the very basic fundamental stuff such as variables, classes, object-oriented principles, and how all of those stuff tied together to form what we know as the Java programming language. Now, you won't have to you don't have to have all of the expertise to learn this topic, because generics is also one of the basic or the fundamental topic, but it actually builds upon on the other topics like variables, classes, methods, and these are the very important topics, because if you do not understand what they are, then it will be a little bit hard for you when it comes to understanding generics. Now, generics is the reason why generics has been introduced into the Java suite, or more specifically the programming languages suite, is because there were issues before JDK 7. I guess it's the right version that I'm stating here, but JDK 7 actually introduced generics. But before JDK 7, the codes that were written, they were not actually type safe. So what generics does is that they make our codes type safe. This might not be a very important aspect from the user end, or the people or the application user who are actually using your program, but this would be very important when it comes to programmers, software engineers, and application developers, because if you're not using type safety mechanism, then you can actually, or probably someone else would take up your code and they would use data types that are not what you wanted inside your application. So it actually enforces or constrains the use of type safety data types, and it makes it very safer in terms of types. So what generics uses is what we know as the parameterized types. Now think of it like when we use methods, we might pass in parameters so that we can use those parameters to pass argument at runtime. But when it comes to classes, we do not have that mechanism. What generics does is that it adds that mechanism. We'll be looking at examples obviously, but it's just the introduction. So let's get started. We first talked about all those advantages and disadvantages and what you should do. Then I'm going to explain to you what generics is and how it is related with type safety. Now, before we get into the explanation, let me just start off with an example. So let us first create a new project. I guess you won't be able to see that. I mean, creation of project is literally very easy. Let's do it. Okay, let's create a Java project and let's call this generics example, and we are going to create on JRE8. Okay, let's finish this off. Now we have our generics example folder, and then we're going to create few classes inside this folder. So first, let me create a new class called generics first example, maybe. I mean, you can create any name for a class, but because this is the first example in this tutorial, I'm going to create a name that's generics first example. And then, do I need the public static void? No, I'm going to create this main function in a different class so that I can actually separate the organization, or my classes are very much distinct in one single folder. I want to do that. You actually do that in a real life application if you are a programmer. At least if you're a seasoned programmer, which is like you're not exactly a professional, but you do use programming very often, then you would know that you have to separate your classes in their separate distinct files. So what I will do is that create a package inside here, and because I will have a package, I will place all my classes inside that package so that I can call them when I'm going to execute my program through my main method. So let me just finish this off. And here I have a class. Now this is a very simple class. Okay, that was a default package, but I can create another package. Let's do that. I want a new package. Let's call this maybe simply generics tutorial. Okay. And I shouldn't have done that, but that's my mistake. I should have actually created that. So let me just erase this off. Okay. And I'm going to do that again. Generics first example. Okay, there we go. And we have our package in here. Then I could have just simply added that code inside my class, but nonetheless, if you are not quite familiar with this Eclipse or how to create that, then that was a short tutorial for that. But nonetheless, let's get into our discussion and let's get into this example. So how do we create generics? Now, generics is basically a parameterized type. So the reason why we use parameterized type, or why it is so important after the release of JDK 7 and why there is so much code involved with generics is because it gives you the type safety mechanism that was not available in the pre-generics era. Or what programmers did, they used to create they used to create a class, then maybe they used to use or explicit casting to translate their codes into different types. So if you're not quite familiar with casting, a simple example of casting would be like consider a person X and a person Y. Now person X speaks English, whereas person Y speaks French. Now the French guy who doesn't understand English needs to have a translator who can translate all the English that's person X is saying into French, so that person Y can communicate through the translator to the guy who's speaking English. So the translator is actually casting English into French or translating English into French, although that might be not a general case scenario or an applicable example for our programming perspective, but that actually serves the purpose of explaining what casting actually does inside our programming, inside the programming interface, or how you create programs. So what casting does, if you have two data types, like if you have two variables with two distinct data types. For example, if you have a data type variable with a data type of integer and you created another data type that you created another variable with a data type of float, then if you want to cast that floating data type, that variable with the data type of float into integer, then you have to use a special form of operator, to a unary operator, to translate that or store that float variable's value inside the integer variable. So what in generics, you don't have to explicitly do that. When you write the code, or when you write when you create the class, a generic class, the Java compiler will do that implicitly, or it will do that behind the scenes for you. So what we are going to do is pass in the type. And how do we pass in the type? It's very simple. All you have to do is just use angle brackets just by just beside the name of the class that you have created, and then use a parameter like this. So what we have done is we have added angle brackets, and inside that angle bracket we have added a letter T. Now that letter T is not actually a vocabulary of the generics, it's just an arbitrary, which means when I create an instance of this class, I will pass in a type as an argument inside this parameter, and this will be used inside my class, and this will ensure all sorts of type safety mechanism. Now, because type safety was actually lacking, in order to streamline all the process and enable the compiler to implicitly cast your variables data types, we have to use this form of generics. Now, generics doesn't only take in one sort of type, it can take multiple types. It can even extend its superclasses, or it can even exclude the it can use another sort of wildcard, which is when you don't know how to or what your user is going to pass in inside this parameters type. So let me get back to this example. So what we have done, we have used an angle bracket. We have used angle brackets, and we have typed in a T, which means if I create a variable before, what would I have? I would have done something like this: int maybe a num. Right? So that's a variable declaration that you would have done previously, but now you don't have to do that. So for example, your class is going to serve two purposes. You're going to allow your users to pass in an integer so that they can create variables inside the class, or create instance variables inside the class, which will be of type integer. And you also want your class to be used as a string holder. Or which that if you want your users to use this class and you want your class to take in string values, then you can do that through this parameters type. If you don't use generics, it would be hard, or if not hard, it would be a lengthy code. So we don't want a lengthy code all sitting inside our compiler, because it takes time to compile and run the code. We don't want that. We want a generic or a generalized form of class that would take integers and strings. So how do you do that? We're not going to write int or integer explicitly, or we're not going to declare a variable of type integer. What we are going to do, we are going to declare a variable of type T, which means when your user passes in an integer instead of T, or replaces the T with an integer inside this curly bracket, your T in here will automatically get replaced with the appropriate type that your users want. And in this case, if our user wants, or if the user passes in an integer inside this curly bracket when the instance is created, and we'll see how that instance will be created when we create our main method. And when that instance is created, that the compiler will take that string, or will take that parameter, which is the string, and replace that parameter, replace this T with that string parameter. Or if we could more simply demonstrate, is that if the user passes in something like this, string instead of T, this thing T will also become something like this. So that's the idea, or that's the generalization that we all need to do inside our codes, because if we can't generalize, our code won't be decoupled, or it becomes, very much hard-coded, coupled inside a specific implementation. So there is a general rule that it's more philosophical, but that's a approach that most programmers or professionals use, and that is and the main point, or the idea behind, is that you have to write a code that's not coupled, or that's not geared towards your implementation, that you have to write your code that is more inclined towards your interface. So what we are doing in here, we are just generalizing the data type that can be passed in here. Now you have to understand that we're doing two things together. One, we are actually following the rules of generalization, and 2, where we are only going to allow our users to pass in what we want or what sort of data type we want that we can manipulate inside our class. We don't want any sort of arbitrary data types to be passed inside our class. That's one of the other advantages that was not available in the pre-generics Java programming suite. So let's just erase this off and replace it with T, and then maybe we could just change the variable's name, something like object, and then let's use it. Let's create a constructor, something like this, and then we're going to use, or we're going to pass in a parameter of O, and then this O is going to be stored inside our instance obj. Okay, now we're going to return the value. We're going to return the instance of this class. And how do we do that? It's very simple. The instance that we're going to return is of parameterized type. So how do you do that? It's very simple, and we do that by get object, and we're not going to pass in any sort of parameters inside here because we know what we're going to return. We're going to return, this is a getter method. So getter methods usually, in usual sense, don't take in parameters if we're thinking very simply, but it's the setter methods. If you're not quite familiar with setters and getters are like, let me just review one more time what are setter methods and what are getter methods. Now, the setter method is that if you want to set in a value, if you want to, for example, set a value inside a class, or maybe you want to pass a number inside your class's instance, you have created an object or object instance inside your main method, and you want to set a value of 1 inside your class. And how do you do that? You don't necessarily actually open up the class. You want your class to be it needs to have proper accessor modifiers, or it means that you do not want your variables to be open to the entire world. So how do you set the value inside your class instance as variable? You write setter methods, and setter methods are usually written like this: public void, because there are not necessarily return types. If you want to return a value, which means if you want to return something from a setter method when the operation succeeds, then you could do that. You could actually return a number like 0 if it succeeds, and if it fails you could return -1. You could do that, but I'm not going to do that. It's not necessarily important, but it's an option. So set val, and then you would have passed in something like this, int num, and inside here this obj num. So what it necessarily does now, it should have been something like this too, because there would have been a problem with casting maybe. So in order to ensure type safety explicitly, or the programmer has to ensure type safety by himself when generic code is not used, then what it would have done is that if I had passed in an arbitrary parameter, then it would have caused a runtime or a compile time error when the compiler actually runs the code. So that's a different sort of discussion, but what I'm getting into here is that I'm going to, when I create an instance, if I create an instance, something like this, just forget that, just for the moment, forget there is no generics involved in here. And let's also say that we don't have a constructor. Oops, I should have commented out rather than that. Okay, so there we go. And We don't need that. Now, for example, although this is not a complete example, but just for the sake of understanding, let's say that we want to create an object of generics, something like this. Okay, and let's call it maybe ABC. That's just a random name, and it's a horrible name, but nonetheless, generics. First example, and there we go. We have our object called ABC, in which we have stored an instance of this generics first example. Now you could actually ignore these errors because this is not a complete code, and I'm just doing it for the understanding of the setter method. So what would be the process of how would we do this inside our using the set value method, which is we're writing a setter method and we want to pass in a number. It's very simple. What we do, we call in the set val method and we pass in 1. So what it does is that it actually protects the instance variable obj, which is contained inside this. This could have a private int object, which means it has a private access modifier, and it necessarily hides the implementation of an instance variable from the outside world. Nobody can access it, nobody can see it, nobody can even see what's inside that obj instance variable. But if we want to manipulate the value, if we want to manipulate, for example, if we want to set a value inside the instance method, and if we want to see what's going on or what the value is inside that instance method, then we use a setter and a getter method. A setter method will set the value and a getter method will get the value, and that's how we do that. You could also, I could also go forward and write a getter method and get val. This way we are going to return the value, this obj. So what it necessarily does, and if you look at the return types of these methods, then you would clearly see that there is a difference, which means when I'm setting a value, I don't necessarily need a return type. All I'm just doing is that getting a value from the user, and I'm setting that inside my class's instance variable. And then if I want to see what's stored inside that variable or what's stored inside that instance method, then all I'm going to do is that get val, and this is going to give me what's stored inside that instance variable. Now this is important if you're not quite familiar with if you have an understanding problem of what access modifiers are, which means how do we hide implementation from the outside world? How do we hide variables inside the class from the rest of the world, and how do we hide methods from the rest of the world inside a specific class? We can use access modifiers, which are like private, public, and protected. So this is not exactly a tutorial about access modifiers, but I'm just refreshing if you have forgotten them. So the access modifiers will allow you to only access according to what has been said by the programmer. Now, because I've said that, I have said that my obj instance variable will be private, only methods can access them inside the class's implementation. And if you get out of the class's implementation, you won't be able to even see what's inside that variable. You won't be able to see you won't be able to set a value inside that variable. So to do that, or to set a value and get the value, we use a set value and a get value method. So let's get back to our real example. This was just a sort of trailer, maybe. Let's erase this off, and we need to get back to where we were. So let's pass in t, and we want to say that our obj instance variable will be of type t, and then we need a constructor. Now again, the constructor is also working like a set value or a setter method, because if you look closely, what we are doing is that we are creating, or we are passing, a parameter of type t inside our constructor, and then we are actually taking the value from that variable o, and we are setting that value inside our instance variable called obj. So we are also setting a value. This is equivalent, or it's similar to what we have seen with the setter method. Now we need to get into the getter method, which is get object, return this obj, and we're going to do one more thing, and that is we're going to see the type, or what sort of type we are going to pass in, and we're going to see if that type has actually been taken inside the class during compile time. So if you're a little confused about what's going on, you will get a clearer view once we get into the implementation of the main method. So let's bring in system.out.println, and inside this println function we're going to say maybe type of t, or type that you have passed inside is, that's a big sentence, I guess. Nonetheless, let's say we want to see this obj. We're going to get the class, and then we're going to get we're going to use a get name. So this is going to give us the type of parameter, the type of data type that has been passed inside our class. I guess I made a mistake. Okay, now we are good to go. Now we need to create the main method, and it's very simple. If you have forgotten, then you can follow along. We need to say this is generics main, and this will be public, and it's good to go. This will be inside this package, and let's import the class. Class was okay. Now what I've done in here is that I've called the generics first class, first example, which I've created previously, and then I'm calling that function. I'm calling that class inside my main inside this separate class that I've created for this main method. Okay, let's erase this off, and then what we're going to do is that we are now going to create an object, or more precisely, we're going to create declare an object of type for generics first example. So let's do that. Generics first example, and then this is a little different because you have to pass in a type. We need to use the angle bracket again, and we need to pass in a class like this. This actually means maybe we could say int val. Now we have an object without an instance. In here we could actually create the instance together like this. It's no harm. You could actually, there's no harm in doing this, but you could declare you could actually declare an object in a separate line, and then you could assign an instance to that object in another line. But you could do that all together in one single line, because that's quite time consuming if you do that in a separate line. Nonetheless, let's get back to the example, and we are going to assign an instance, and we do that by calling in the class example, and then we pass in integer, and now we're going to pass in a value, something like maybe 100. Now you have an object with an instance, and if you look at the declaration of this object and the assignment of an instance, it's a little bit different than what you have experienced in the past. If you have learned about how to create instances from Java classes without generics, then you would actually recognize this construct or this syntax. The only difference it has is that we are passing a data type or an integer class, which is a wrapper class, inside angle brackets, and we're doing the same thing even when we are creating an instance. So this actually is the same thing. If you could remove this, you would see the same thing. So this is the class, and we have passed in a value inside the constructor. The only difference is that we have an integer wrapper class. Now remember that you can't actually pass in the primitive data types, which are like int. You can't write that. That would actually contain an error. So you already see that my ID is pointing out that this is not acceptable. So let's change this to integer. Let's get this to integer, and we are good to go. And then what I'm going to do is that I'm going to take in or get the value inside another integer. Now this is actually applicable, and this is, you could do this. Now let's create num, and because we already have the object, and we're going to get the get object. So inside this num, this is this is allowed inside this. This is did I make a mistake? No. This is allowed in terms because what we are doing in here is that we are setting a value 100 inside this. We're passing an argument of 100 inside this constructor, and then we are setting the value of that argument inside our instance. And then when our instance also contains the value of 100, we are going to return that value. We're going to return that value to our variable called num. Our variable, which is of type int, is going to store the value of 100. And there is interesting catch in here. You will actually see that what I'm doing in here, I'm not using any sort of primitive type. I'm not using int, because that's not allowed. What I'm using is a class wrapper, which is integer class. So integer class is quite different than the primitive type of int. It means that there is an implicit casting going on behind the scene when you compile the code using your compiler. So it means that although you have created a value of 100 and set that value inside the constructor, it means you have auto boxing features already turned on for your generics. And when that auto boxing feature is turned on, this value of int, this is also a primitive type. This 100 is actually it actually has a data type of int, which is a primitive type. It is going to get converted or casted or translated into an integer classes instance. So this instance is going to be stored inside this class, and then when I actually return the value using this get object method, it's going to auto unbox that value, which means previously our value of type int, which was 100, was casted into integer wrapper class, and then when we do the get object, when we call the get object method, it's going to get casted back from integer classes instance into a primitive type of int. That's why we can store that value inside a variable with a data type of int. Now we're going to print that out. You'll see that we won't face any problem if we do that. So let's say num, your value is num and okay, there is a mistake. And then what we're going to do is that we're going to also call the show type, which is we created a method to understand if our class has actually taken the type that we have passed in as a parameter inside our generic class. So this is a parameterized type. In here we are passing an argument that will replace this t for this entire class. So let's call that, and let's see system.out print line, and type 1 is, this will be int val, and I'm going to get the show type method, and I'm good to go in here. Is there a problem? What's the problem? Is undefined for argument type s. I think I made a mistake somewhere. Sorry. I already have the system.out print line. I don't need that again. So all I have to do is that I need to remove this. And then let's save this and let's run the code. So if you look into this console inside my Eclipse, then you'd see that I have got the value, which is what I've typed in here. Your value is 100. Type that you have passed inside is java-lang integer, and this integer is a class that is contained inside this package. Now the interesting part in here is that all this casting is handled in compile time by our compiler. We don't have to do that exclusively. We don't have to do that explicitly inside our code, and this has made our code a lot simpler, and it's actually quite short. Otherwise, casting would have caused us to create lengthy code, or code that's quite unmanageable. So let's create another type. Now this time I'm going to create a string type, and I'm going to pass that inside my generics first example.